All right, let's talk about electric potential difference. If I have two like charges, both positive, if I wanted to move them towards each other, these things repel. Yes, and I would need to do work. Yes, and the same thing would happen if I had two oppositely charged objects and they are attracted to each other. So if I wanted to separate them, I would have to do work. Um, and electric potential energy is going to be involved here. If I squeeze these together, they are dying to get away from each other, so it's a lot of pent-up energy. So we call it it is electric potential energy. Um, the amount of electric potential energy would depend on how much charge we're moving. So we don't often just talk about how much energy is involved here. We're interested in how much energy per charge. So we have this formula we use for electric potential difference. It's how much work we do per unit charge. And this is work in joules. This is charge in coulombs, and this is electric potential difference, and it is measured in volts with a capital V. Okay? And keeping in mind that work has units of joules, so work is equal to energy, so it could be the exact same thing. I could use V is E over Q. No big difference. 1 volt is the electric potential difference between 2 points if it takes 1 joule of energy to move 1 coulomb of charge. And in general, people on the street, non-physicists, they don't use the term electric potential difference. They just use the term voltage. It's very common, and you'll hear me and other physicists use it too, because it is that pervasive in our culture. If I'm going to measure electric potential difference, I use a voltmeter. There it is there. But unlike the ammeter from the last video, this voltmeter is connected in parallel. So here's my battery. Here's some load, resistor, fan, whatever you want to say it. And I hook it up in parallel. If I'm interested in how much electric potential difference, what's the electric potential difference drop here from when the electricity before it enters to when it comes out, I need to hook up those two spots with my voltmeter. Yes, so it's measuring the energy before and the energy after it goes through the resistor, the worst resistor ever. So I've hooked this up in parallel. Yes. Oh, and look, I've already rewritten this. Work is done as measured in joules. It's equal to energy used. So yes, electric potential can be E over T. Yes. Okay. So let's see if I can remember this equation. How much energy one is using is not an easy thing to measure. Current is a much easier thing, and I know that I is equal to Q over T. Yes. So if I have V is equal to energy over time. Sorry, complete mistake there. Not time. Let's change that guy. V is energy over charge, and so therefore E is, voltage is energy over charge, so E is Q times V. But from up here, I know that Q is equal to IT, so I'm going to take this and I'm going to put it right there, and instead I'm going to get energy is equal not Q, I'm going to put I, T, and V. So how much energy you use in your home is equal to how much current is running through the device that you're using, how long it is on, and what the potential difference is. And in Canada, we usually use about 110 volts. Different amount of current will go through every different, will be different for every object, and the time you have it on is dependent on how much you're using it. So that's a quick look at electric potential difference. I hope you enjoyed the video.